Hello, third graders. Welcome. We are ready to start lesson 9.5. Can you believe how far we are this year? We have done so much great math work. Today, we need to know what a word means. And you've seen this word before, but I really want us to understand the word partition. Okay, partition sounds kind of like the beginning. You hear the word part. That's what partition is. Partition is to split something into parts. And so you can see this person cutting all of these lovely vegetables, partitioning them into different pieces. Boy, my son would just love those vegetables.
Yeah, right.
Oh man, he said no. But they're so good for you. All right, let's get on to the objective, right, which is being able to partition some rectangles. We're going to split rectangles into parts to solve a multiple digit multiplication problem. Okay, and so we're going to start here on Math Journal page 286. I need you to open that now. And here is our question. Let's see. Can we make this even bigger? Jonah's garden is a rectangle with 16 rows for plants. He wants to plant two sections, one with 10 rows of carrots and the other with 6 rows of beans. Oh, look, more vegetables today. It is a vegetable-y kind of day. Partition the rectangle and label the sections carrots and beans to show how Jonah could plant his garden. All right, let's do this together here, right? So this is his garden, and we need to partition this rectangle. That means to split it into parts. So we need 10 rows of carrots. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to be drawing a line right here. And actually, I'm going to use my fancy line tool here to draw a line straight across there. Watch out. It's going to turn nice and straight when I'm done here. Boop. Oh, well, kind of. Straight enough, right? So we have 10 rows of carrots, right? Let's do C. Well, that didn't work. Let's write on this and do C for carrots. O for 2. Now, C for carrots. And then 6 rows of beans down here for beans. So we got the carrots and the beans. Okay, you should do this along with me. Now, we are going to then look at the question down at the bottom. Jonah can plant 9 seeds in each row. How many seeds can he plant altogether? Well, let's go back to our picture. And we're going to, let's see, we need 9 seeds. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're using all of them, right? So he can do all, right? 9, 9, 9, 9. You don't want to watch me put dots in every single one of these, nor do you need to. But let's think about, we would do, in order to figure out how many squares are here, well, we know that this is 9 across and that it is 10 wide, right? And you know area really well, right? To find the area, to find how much is in there, we would do 9 times 10, which equals 90. What math problem would we do to find out how many squares are in the beans part? We need to do 9, right? It's 9 across. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 6 tall. 1, 2, 3, 4, 5, 6. 9 times 6. 9 times 6 is 54. And then to get the total to all of it, of course, right? We're going to add these up. And our answer here is that he is, for the whole section, is that he is going to plant 144 seeds. See how that works, right? We took this great big area and then we found the amount that is in each part and then put them together, right? Because otherwise we would have had to try 9 times 16, and maybe we're ready for that and maybe not. Okay. All right, moving along. And I'm actually going to get rid of some things here because I want to show you this all from the start. So Meg bought 7 boxes of crackers. Each box had 62 crackers. How many crackers did Meg buy? She must have been having a party or something, right? And so what we are going to do, right, this is going to be a very big number. My brain says multiply, right, because I'm going to have 7 groups of 62. So I am going to partition a rectangle, right? I'm going to draw my rectangle. This is what you're going to be doing. And then 62, this is the one I'm going to split up. I'm going to make it 60, and I'm going to chop off the 2. All right, here we go. Chop off that last number. So the 2 goes here, and the 60 right there. All right, see how that's 60 and 2? Times 7. Okay, and so in this box, what's going to go here? 7 times 60. What is 7 times 60? It is 420. If you didn't get 420, that probably means that you aren't sure about 7 times 6. Okay, so that's one to practice. Remember Mr. White's little poem, 6 and 7 went on a date and ordered a table. 4-2, right? 4-2, 42. And then over here, we're going to do 7 times 2. What goes in this last box? 14. So look and see. Look, right? This is the exact same thing that we were doing over here. Nope, not there. Right here. Okay, right? We took, this one has squares, and all we've done, the only difference is that now we're not going to draw all the squares, because no way in the world that anyone wants to draw 420 squares inside this rectangle. Okay, and so just like we did at the end on the first problem, we're going to take our 2 parts and put them together, and then we will know the total, right? So we have partitioned this rectangle. 434 crackers. Always label your answer. Now, let's say this is not as common. A lot of people like making this 60 and 2, but let's say I just don't know 7 times 6, but I do know 7 times 3. We could take the 62, chop off the 2, and make this 30 and 30. See how that's the same and how it's different, right? And then we're going to multiply times 7. So let's have you tell me, how is this one the same as this one? How's it the same? Okay, we're still multiplying the same total numbers. We have 62 on the top here, right? The 62 on the top here just written differently, right? And we're multiplying times 7. So we'd have 7 times, I'm thinking about the answer already. 7 times 30, which equals 210. Another 7 times 30, which equals 210 again. And then 2 times 7, which equals 14. We put those all together. I bet we get the same answer. 4, 3, 4. There it is, 434. So you could partition it differently. Although I will tell you, a lot of people like to just take the 6, make it 60, and the 2, make it 2. Let's practice. Let's see. Let's practice one more. Okay, you can see that's just a nice, pretty copy of what we were doing, what Mr. White was drawing. Before we get to our math journal, let's just practice another one. Let's practice 45 times 3. All right. Grab your notebook, grab your paper. You're going to need to do this. Draw a rectangle here. What is the first step? Okay, we're going to partition the rectangle. We're going to split it into parts. Let's take the 45, and what should I put right here? the 5. And what should I put right here? The 40. Now, could you have said 20 and 20 or 30 and 10? Yes, but 40 is going to usually be, a lot of people are pretty comfortable with their 4s. Where does the 3 go? Goes on the end. All right. Here we're going to do 3 times 40. It's just like a multiplication table, only we don't have the answers. What's the answer for 3 times 40? 120. And then what's the number sentence? Give me the whole number sentence with the answer for that box. It is 5 times 3 equals 15. And what do I need to do with these two numbers at the end? Add them together. This might be one you can do with mental math, at least on this problem. 135. All right, your math journal page. It is right here. It is math journal page 287. And you are going to be breaking apart the multiplication problems. Okay, so we're going to break it 24 into, most people here are going to write 20 and 4 because I bet you can figure out what 20 times 7 is. Okay, so this is where you're going to draw the rectangle. That space should not be blank, right? And then we have 4 times 36 and 8 times 57. All right, we are partitioning rectangles today, right? This is part of our standard. Now, I will tell you, our standard says to divide within 100, right? So some of these are going to go above 100, and that's how the world works, right? The numbers go past that. So our goal to be able to partition rectangles to solve multi-digit multiplication problems. All right, reach out to me if you need any help, and good luck.